All right, I believe we're on almost the home front here. So we are now going to be talking about electrons and the locations we find electrons. So the location you find electrons is called an orbital. Now, orbitals have different shapes. As you can see here, this is what's called a 1s orbital. It's really small. This part right here, that little purple part, is the nucleus. And then this area that goes around it, that is the first orbital. And essentially, in that orbital, you can find 2 electrons hanging out in there. You can find only one, but electrons, just to let you know, like to be in pairs. Kind of like us. We're more stable when we're together. I mean, we all have that crazy friend that does crazy body shots and out partying till 2 or 3 o'clock in the morning. But as soon as they find a boyfriend or a girlfriend, they're in every night, making sure to be really good, going to church on Sunday, and they just more stable when they're in that relationship. And electrons work the exact same way. Always stress to people, make sure that you just, when you study, look at the behavior at what you're studying and try to relate it to somebody you know. And it's amazing how much atoms and molecules act like people. Now, do you see how this one's bigger? That first shell here, if we were to put it in here, would be about like that. Now, this one fits on the outside of that. And this is what's known as a 2s orbital. And this is the second orbital out. In here, you have 2 more electrons hanging out in there. And these are all what are called p orbitals. And they look like the figure 8, right? And they're basically 2 electrons in each one of these. And essentially, you can find electrons anywhere in those areas. There are these, like I said, these kind of clouds of negative energy, and they can be found anywhere in those areas. Now, they can be found about 99% of the time in these orbitals. But there's a fraction of a percent of the time where they have absolutely no idea where they are. And that field of chemistry is pretty interesting to kind of go into. They have things known as quantum entanglement theory, where they talk about how electrons from one entity can interact with electrons from another without really ever forming a bond. It's pretty wackadoodle crazy stuff, but it's very, very interesting. Now this guy down here, this is neon. And this is neon with all his orbitals. So if you look here in the center, that is the first orbital that's in there. And if you look here on the outside, that circle part right here, that's that 1s. And then you can see what looks like petals on the inside, because that's essentially all of these different orbitals. So how this works is that the electrons, very specific electrons, can only be found in certain areas, but those areas can overlap, right? So that's essentially how it works. I was trying to think of a good example off the top of my head. It would be kind of the idea that, you know, for the most part, I'm going to be in my office and I'm going to stay in my office. And that's where I'm going to work. But say someone that is in the custodial staff has access to my office and the whole floor. So you can find them anywhere. They're kind of overlapping, where essentially my main place is my office. So that's kind of how I think of this, right? That this guy right here, he can only hang out in that area. But this guy can hang out in his area and farther out. So, but they essentially all overlap, most of them. Now, this is different, there you go, than what are called, let me go through here, what are called shells. Now, these are orbitals. Shells, darn it, I'm sorry guys. Shells have to do with energy level. Now, basically, the closer that the electrons are to the center, the less energy they have. The farther out they are, the more energy, right? And you can think of about it in the sense of if you are basically right next to a building, you're holding on. That's going to take less energy than if you essentially are hanging farther off the building. It's the idea that electrons, to try to keep the electrons centered or close to the nucleus, it takes them more energy to kind of stay in place than the farther in. So how it works here is nucleus here, less energy close, more energy towards the outside. Now shells can fit multiple electrons within them. And essentially you are trying to fill the shells. Filling the shells make electrons or the atoms, let me just put atoms, stable or happy. Now, each one, and we're only going to do 3, it gets more complicated. They get more complicated as you get out. So the first shell can have 2, and they need 2 in that shell for it to be stable. The second shell needs 8, and the third shell needs 8, right? So let me compare what shells are to orbitals. So this right here is the first orbital, right? Well, that is also the first shell. So when we look at that, do you see that? That is this one right here. So you can have only 1 electron in there, but it's not going to be stable until you have 2. Now the next shell that comes is this guy right here. So this is the second orbital, right? Because this was the first up here. And it's the second shell. But the second shell fits him, 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 and him. Why? Do you see how they're all overlapping down here? Do you see how the petals and the circle all go out to the same distance? That's what puts them at the same amount of energy, or essentially in that same shell. So I'm going to put a heart here, and that's this guy here, okay? So you can have less than 8 in there, but it's not going to be stable. What's going to make it stable is trying to get to 8. So if your atom only has 6 electrons, then it's going to interact with other atoms to try to get the 2 more to make 8 to make it stable. And then essentially this guy right here would be farther out. So hopefully that makes a difference, or helps you understand the difference between what atomic orbitals are and essentially shells. Now, the electrons that are farther out are what are known as valence electrons. They are in the outer shells. Because remember how I said the ones that are farther away have more energy? So they're the most energetic. And when atoms lose, gain, or share electrons, that is what is known as chemical reactivity, or a reaction. If those shells are full, they're not going to react at all. If they're not full, then they're going to react with other atoms to try to make them full. Electrons are needed to fill valence shells. Now, if we gain or lose electrons, so essentially an atom here has an electron, and gives it to the other atom, or if this atom takes it, right? It's gaining or losing. So if he gives it to him, he's going to gain an electron and he'll lose an electron, right? That's what's known in a minute when we'll talk about it in class. That's an ionic bond, right? If atoms share them, so if you have hydrogen here and hydrogen has one, they'll basically take this orbital and they'll share them together. One doesn't take them or the other one receive. Then these are going to be what's known as covalent bonds. And covalent bonds, there's a couple different types here. So, let's go back really quick, and we're almost done here. Actually, I'm going to pause here, and then we're going to get started on, see if you can, let's take oxygen. Tell me how many protons, how many neutrons, how many electrons, how many valence electrons it has, and how many we need for it to be stable. And then I'll start that in the next video, and then we'll be concluded for this set.